Hello everyone, welcome to this new video. So in this today's video, we'll be solving the problem, reach the endpoint. So this is an easy level question and it's the problem of the day on Geeks for Geeks today. The company tags of this question are Morgan Stanley, Amazon and Intel, and the topic tags of this question are dynamic programming and algorithms. Fine. So let us go through the question now. The question says there are n points on the road. You can step ahead by one or two. Fine. So there are n points. Either you can you can take one step or two steps. If you start from point 0, you can only move from point I to point I plus 1 after taking a step of length 1. So if you are looking out to move from point I to point I plus 1, you can only take a step of 1, right? You cannot take two steps to go from I to I plus 1. That's very important. So find out the number of ways to reach point n. Fine. So you'll be given a value of n. You need to figure out how many ways you can reach point n. So these are some of the examples that have been given, and the expected time complexity is O of n and the space complexity is O of n. But we'll be solving the problem in O of 1 space complexity and O of n time complexity. So the n goes up to 10 power 5. These are the constraints, and we need to make sure we are taking the modulo 10 power 9 plus 7 as the value might be very large. And so let us go through the example now. So this is an example that has been given, example 2. So we'll just list out the points first. So this is n equal to 1, this is n equal to 2, this is n equal to 3, this is n equal to 4, this is n equal to 5. Fine. So these are the points that have been given. So I'll leave this thing for framing the approach. Let us now first understand why 8 is the required answer. So what are the ways to reach 5? So they are saying that 1 from 1 from 1 from 1 and 1. So these denote one it starts from 0. Okay, so these 1 denotes the number of steps. Okay, from 0 to 1, if you take a 1 step, you'll be reaching 1, and from 1, if you take a 1 step, you'll be reaching 2. From 2, if you take a 1 step, you'll be reaching 3. From 3, if you take 1 step, you'll be reaching 4. From 4, if you take a 1 step, you'll be reaching 5. So there are total of 5 ones in there. So this is one of the one solution. Okay, so what's another thing? 1 1 2. So that means from 0 to 1, from 1 to 2, from 2 to 3, and directly from 3 to 5. Reason being, you're given a freedom of taking 2 steps, right? So from directly from 3, you can jump to 5. And what's the other thing? So this is also done. Other thing is 0 to 1, from 1 to 2, and from 2 to 4, and from 4 to 5. From 2, you have taken 2 steps. So that is the reason in between we have 2, and then from 4 to 5, 1 step. So this is also done. And what's the other solution? 0 to 1, and from 1 to 3, and 3 to 4, and 4 to 5. So from 1, you have taken a direct jump of 2 steps to 3, and from 3, 1 step 4, and from 4, 1 step 5. So this is also done. And what's the other solution that are there? Some 0 to 2, 2 to 3, 3 to 4, and 4 to 5, right? So what are the steps? From 0, you have directly taken 2 steps, so reach 2, from 2 single step 3, and from 3 single step 4, and for 4 single step 5. So this is also done. And what's the other solution? 0 to 1, from 1 to 3, 3 to 5. 1 step, 2 steps, and 2 steps. So this is also done. And what's the other solution? 0 to 2, 2 to 3, 3 to 5. So take 2 steps, and then 1 step, and then 2 steps. So this is also done. And what's another solution? 0 to 2, 2 to 4, and 4 to 5, right? So take 2 steps here, 2 steps here, and 1 step here. So this is also done. I hope you people understood how did we end up getting all the ways to reach n equal to 5 from n equal to 0. So these are the only possible ways. There is no other possible way. Fine. So I'll just erase these things first so that you can have some better clarity. Okay. Fine. So this is done. Now, how are we going to solve this? Now, let us frame the approach. For the same example, I've taken 5 points. Fine. So now let us list out the number of ways to reach each and every point. Fine. So that's another point as well. I forgot to write that, so I'll just move this behind. So the another point is n equal to 0. Fine, n equal to 0. And your start, what is your start? Start is actually equal to n equal to 0. Okay, start equal to n equal to 0. Now list out the number of ways possible. How many number of ways are possible to reach n equal to 0 from n equal to 0? So because your start point is n equal to 0, how many ways are possible to reach n equal to 0 from n equal to 0? Only one possible, right? If you just stand idle, it is also a way. So only one way is possible to reach from n equal to 0 to n equal to 0. So how many ways can you reach n equal to 1 from n equal to 0? So only by taking a single step. You cannot take 2 steps as mentioned in the question, only 1 step. So from n equal to 0 to n equal to 1, you can take a single step, and so only the number of ways possible is 1 step. One way. Okay, the number of ways is 1 way. And calculate the number of ways to reach n equal to 2. How many ways can you reach n equal to 2? If you list it out, you can take 1 step from n equal to 0 to n equal to 1, and from n equal to 1 to 1 equal to 2. 1 step and 1 step. Or directly, you can take 2 steps. What are those 2 steps? So from n equal to 0 to n equal to 2. Direct 2 steps, right? So this is also another way. Is there any other way possible? No, only 2 ways. So this is 2. Okay, I hope you people understood. So let us erase this. Now, how many ways can you reach n equal to 3 from n equal to 0? So very first, the naive approach would be from n equal to 0, n equal to 1, 1 step, from 1 to 2, 1 step, from 2 to 3, 1 step. Okay, 1, 1, 1. This is one way. And what's another way, another possible way? From 0 to 2, take direct jump of 2 steps, and from 2 to 3, direct jump only jump of 1 step. So this is also another way. What is another way? From 0 to 2, take 0 to 1, take 1 step, and from 1 to 3, take 2 steps. Okay, this is another way. Is there any other way possible? No, only these 3 ways. So total ways are 3 ways. So if you can list, if you want me to list it out, it's like 0 to 1 to 2 to 3. This is 1 step. It's from 0 to 2 3, this is one way, and from 0 to 1 to 3, this is another way. All right, these are the 3 ways possible. So I hope you people understood, and let me erase this as well. So erase these things. Fine. So n equal to 3 is also done. Now coming to n equal to 4. How many ways can you reach n equal to 4? If we list it out one by one. So one step, one step, one step, one step, 1 1 1 1. So by taking one steps, you can reach n equal to 0 to n equal to 4. This is one way. Okay, this is one way. What's another way? From n equal to 0 to n equal to 2, take direct jump of 2 steps, and from n equal to 2 to n equal to 4, take direct jump of 2 steps. So totally in 2 steps and 2 steps, you can get one way as well. So this is also one way. What is another way possible? From n equal to 0 to n equal to 2, take 2 steps, and from n equal to 2 to 3, take 1 step. From n equal to 3 to 4, take 1 step. So this is also one another possible way. And what's another possible way? I'll be using a different ink now. Maybe this. So from this is not visible. From n equal to 0 to n equal to 1, this is one step, and from 1 equal to 1 to 3, this is 2 steps, and from 3 to 4, this is another step. So from in this pattern 1 to 1, this is also another possible way. So what is another possible way that is there for me? Maybe I can try like this final pathway. So from n equal to 0 to n equal to 1, and from n equal to 1 to n equal to 2, and from 2 directly take 4 steps. So 1 1 2. So only these are the number of ways that are possible. So how many ways are there? 5 possible ways. What are those? If you want me to list it out, so from 1 to 2, 2 to 3, 3 to 4, 4 to 5. Okay, from starting from 0. Okay, 0 to 1, 1 to 2. So no 5 here, only 4. So this is one pathway. And what's another pathway? 0 to 1, 1 to 2, and from directly from 2 to 4. Another pathway 0 to 1, 1 to 2, 1 to 3, and from 3 to 4. This is another pathway, right? And what's another pathway? 0 to 2, 2 to 3, and 3 to 4. This is another pathway. And what's another pathway that we are leaving it out now? So 0 to 2, okay, 0 to 2, that is done. And another pathway is, okay, 0 to yeah, this one, 0 to 1, okay, that is also done. Fine, then what are we leaving out? Yeah, this one, 0 to 2, 2 to 4. Fine, this is another pathway. So totally 5 pathways are possible. Only 5 pathways are possible. Fine. So I hope you people understood how did we get this. So I'll even erase this thing for better clarity. And yeah, okay, I'll just erase this stuff as well. This erasing itself is consuming a lot of time. Okay, so 5 steps. Okay, 5 steps. Now I'll not be calculating for n equal to 5. Don't worry, I'll not be doing that adventure. That's going to cost me a lot of time and space. So but now till now what we have done, we'll be taking some pattern identification, and we will try to replicate the same thing for n equal to 5 and try to calculate. Okay, so what did we do? So for n equal to 2, if you have a clear observation on n equal to 2, how can you reach n equal to 2? You can reach n equal to 2 from n equal to 1 or n equal to 0. From n equal to 1, you can take a direct of 1 step. From n equal to 0 to n equal to 2, you can direct take off 2 steps. Okay, so in this fashion you can come. And if you're trying to come to n equal to 3, from which points you can directly come to n equal to 3? From n equal to 1, you can directly come. You can come directly come from n equal to 2. Can you come directly from n equal to 0? That's not possible, right? Why? Because you're not allowed to take a 3-step jump. You can only take 1-step jump or 2-step jump. Okay, so from n equal to 1, you can take 2 steps jump and you can come to n equal to 3. From n equal to 2, you can take 1-step jump and come to n equal to 3. So these are the only possible pathways. So if I just write this relation, just let me know if you people can really accept it or not, right? So n equal to 2 depends on the number of ways to reach n equal to 2 is basically the number of ways to reach n equal to 0 plus number of ways to reach n equal to 1. Can I write this? Absolutely I can, because n equal to 2 can be reached from n equal to 0 to n equal to 1, right? I can reach from both these points. So if I just calculate the number of ways to reach n equal to 0 and n equal to 1, I'm done. I'll just add them up so that I can come to n equal to 2, right? So this is also done. And what if I want to calculate the number of ways to reach n equal to 3? I just need to calculate the number of ways to reach n equal to 2 plus n equal to 1. So if I just add them up, I'll be able to reach n equal to 3. I'll be getting the number of ways to reach n equal to 3. So what if n equal to 4? So it's just that number of ways to reach n equal to 3 plus number of ways to reach n equal to 2, right? So let us see if this relation is actually working out. So according to this relation, what's the number of ways to reach n equal to 2? Number of ways to reach n equal to 0, 1 plus number of ways to reach n equal to 1, 1. So that's actually equal to 2. Yes, it is matching. And come to n equal to 3. Number of ways to reach n equal to 2, that's 2 plus number of ways to reach n equal to 1, that's 1. So total addition is 3. And yes, that is also matching. And come to n equal to 4. Number of ways to reach n equal to 3, 3 plus number of ways to reach n equal to 2, 2. That is also matching. 5 5, right? So this matches, this exactly matches, because it's just that what are we able to see in the picture, that is what we are writing, right? So if you can have listed out all the pathways, see that you can only come to 4 from n equal to 2 to n equal to 3. So if you just add the number of ways of reaching n equal to 2 to n equal to 3, that's done. You are done with the problem. So similarly, how do you calculate number of ways to reach n equal to 5? It's basically number of ways to reach n equal to 4 plus n equal to 3. That is 5 plus 3, that's equal to 8. So that is the reason 8 is the answer. I hope you people understood. So you can just replicate the same thing in the code. So if you actually observe, it's like the addition of previous two numbers to get the present number, previous two numbers to get the present number. So it's the Fibonacci series. That's it, Fibonacci series. So we will not be using an extra space. The reason being, I'm only dependent upon the last two things. For calculating n equal to 2, I just need n equal to 0 and n equal to 1. For calculating n equal to 3, I just need n equal to 2 and n equal to 1. For calculating n equal to 4, I just need n equal to 3 and n equal to 2. Only the previous things is what are needed. So I'll be taking that, updating after every iteration. From the last 2 days, we were doing these type of problems, exempting the usage of space, directly, updating after every iteration. So we'll follow the same pattern and code it up. Okay. So what is that I'm saying? So I can take that into previous. In previous is actually equal to 1. So previous in the sense, first at this beginning, 0th step, how many ways to reach 0th point? So that is actually equal to 1. And you can write previous second. You can just write this out, and previous first. Okay, previous first is the number of points to reach n equal to 1, that is 1. And we'll take mod to be 1e9 plus 7, and steps or ways to be equal to 0. So what am I doing? For every ith step equal to 2, from step 2, okay, from nth step, you can just write nth step equal to 2 till nth step not equal to n. Okay, nth step not equal to, less than or equal to n, nth step plus plus. Okay, nth step plus plus. So how are you going to do? Your current number of ways is actually equal to, it depends on previous first and previous second. So previous first whole mod plus previous second mod. Okay, and the overall thing, you'll take mod just to be on the safer side. Okay, and then what will you be doing? This, after this, you'll be updating this to your previous first, and before that you need to update your previous second. Previous second would be your previous first, and your previous first would be equal to ways. Okay, and finally you will be returning the ways. I hope you people are understanding what are we actually trying to do. So if we just put it on notepad, so for first calculating for n equal to 3, it's like this. The train pattern is like this. So if I just list it out, n equal to 0, n equal to 1, n equal to 2, n equal to 3, n equal to 4, and n equal to 5. Okay, let us assume we are calculating the number of ways to reach n equal to 5. Initially we know that number of ways to reach n equal to 0 is 1, and n equal to 1 is 1. Now if you are trying to calculate from n equal to 2, this would be your, previous second, and this would be your previous first. Okay, and now you are adding them up and you're getting some value. And now to calculate this point, if you wanted to calculate for this n equal to 3, and for this, now after calculation we'll be getting 2, 1 plus 1 equal to 2. If you're calculating for n equal to 3, your previous first must be this, right? Previous first must be this. What is this in the sense 2, this equal to 2. And your previous second must be this, right? This would be your previous second. So this is how we are updating. After every iteration, we are putting this previous first to be number of ways, and before that we need to update previous second to previous first, and then from previous first to the number of ways. So this is what you're doing. And after calculating for n equal to 3, this time this would be your previous first now, and this would be your previous second. For calculating n equal to 4, and this goes on, this train goes on till you reach n equal to 5. I hope you people understood. Let us submit the code and check for your reference. Okay, so wait, so I did a small mistake. Where did I do that? In previous second equal to 1, previous first equal to 1, and from n step not equal to n step plus plus, ways equal to previous first whole mod plus previous second whole mod, and then I'm updating my previous second to previous first, and then I'm putting that previous first to be the ways. Okay, so am I missing something? Am I missing anything here? 1 plus 1 2, my previous second is previous first, and previous first is, and I think I'm doing it perfectly. I don't know what is the reason. Okay, so let me try doing this previous first. Okay, previous first. This must not make any difference, to be honest. Let me check. Okay. Yeah, this is working. I don't think so. Why base is not working? So after coming to this base, this must work, I guess. Why is it not working? Why? Okay, so the reason being, if your n is actually less than, got it. So previous first works if your n is actually less than 2, because if it's less than 2, we'll not be going into this for loop, and because we are initiating it with 0, you'll be getting a wrong answer. So you understand, like, previous first is the better thing to return. Okay, got it. So that's one of the reason. I hope you people understand. So it's a good thing to actually check all these things before you people, so that you can also learn these things and avoid these type of mistakes in future, right? So for your reference, codes in C++, Java, Python are there in the description. Please go through them, and if there are any doubts, please feel free to comment in the comment section. And thank you for watching, guys. stay tuned. I know this video is lengthy, but in any sort of problems in the similar lines, if you see the solution, you'll definitely able to solve that question. I have explained in such a way, developing the intuition from every starting point. This is what we are doing. This is what we were doing from last 2 videos, right? So, and exempting the usage of excessive space. So all these things will really help you in the solving any sort of problems in the similar lines, right? So yes, thank you guys for watching and stay tuned.